Thanks, everybody, for coming out early. I'm going to go through a couple of slides first just to give a little bit of perspective. Adam did a great job describing the kind of inspiration around restaking, which is to bring the ability for us to actually move the cloud into the crypto space. And, I'll kind of go through two different perspectives on looking at EigenLayer. One is going to be from the blockchain side. There's a lot of blockchain protocols out there. We'll kind of go through how they form, in a sense, their own SaaS kind of middleware system. You connect to all of them in order to build your blockchain dApps. And then I'll flip over and I'll talk about what Adam was saying at the end, which is the larger Web 2 cloud opportunity. Because as we know, in the technology space, we have a tremendous amount of building happening there. So first, just kind of establishing from the fundamentals, what is EigenLayer? I'm going to go through this slide and break it down in two steps. So this is what we have right now in Ethereum. You have the Ethereum token. You have a consensus protocol, which is the beacon chain, a bunch of peer-to-peer nodes that communicate over the internet. And they basically do consensus on an EVM. And inside of the EVM, dApps like AMMs, like Uniswap, or literally anything that you want to build, you code it up as smart contracts, and the protocol runs. And then I don't know what the hell happened to my dApp picture, but just imagine some big, beautiful dApp drawing there. Okay. So now EigenLayer comes in the picture. And some of the words are a little hard to see at the bottom here. Let me move this out of the way. So the idea in EigenLayer is you take the same ETH tokens, which you're already using inside of the consensus protocol of Ethereum, and you use them a second time in order to secure faults that are happening in new networks of AVSs. And I want to distinguish an AVS from an EVM-based protocol. An AVS is any generalized software protocol that you can run as distributed peer-to-peer nodes. In a sense, Ethereum itself is a peer-to-peer node protocol. So this allows people to create new protocols using Ethereum token that are, in a sense, first-class citizens. They are not based on side of much more restricted EVM. They're allowed to use essentially the entire history of computer science technology in order to build them. And that means basically you can use this general purpose for anything. So this is a general SaaS technology for building any kind of software. So, and then over here where you have the dApps, the dApp now is allowing you to fuse together what we have now, which is EVM-based protocols, together with a whole bunch of services down here. So what are the services? So inside of the blockchain side, in this first part of the talk, we can look at a couple services we know now. In roll-up services, we have sequencing, bridges, MEV, watchtowers in order to give us fault tolerance, coprocessors, AI inference, databases, ZK provers, lots of stuff in cryptography. We also have things that are related to service level agreements. Everybody knows Filecoin for proof of storage. We have Witness Chain now, which was a SaaS function in blockchains. Allows you to actually prove where hardware nodes are running. Quite valuable, if you think about it. I mean, you can tell a lot about sibling if you see you really have 40 different countries versus 40,000 servers that all appear to be coming out of Amsterdam running your protocol. Proof of machinehood and proof of identity. So just a whole bunch of kind of SaaS services that you would have in the middleware space. And all of these are being built by various partners on top of the EigenLayer platform. EigenLayer shared security, which I showed in the last slide, is the basis of all of that. And then we have a couple of really important AVSs that we're building in-house. DA, EigenCert, which is a signature aggregation scheme. There's going to be a few more of those. And why are we doing something like building DA? I mean, obviously people know there's some other DA providers out there. And it's literally because, we kind of can't help ourselves. There's much better that you can do with DA than the technologies that are out there. And so we wanted to make sure we had the best DA possible available on EigenLayer. So if I threw a slide down here with the numbers. Ethereum's around 80 kilobytes per second, EIP 4844. both increases the amount of data you can use in Ethereum. It also drops the cost by a factor of 4 or 8, pretty high. Eventually, we're going to have Donkrod's donk sharding that bumps us up. But if you look at EigenDA today, we launched with 10 megabytes per second, and we have a roadmap. There's really no restriction on us, just a factor of horizontal scaling to get to over a gigabyte per second, and even a roadmap beyond that. There's no actual bottleneck we'd have there. And so that both takes the costs way down on DA, and it also far exceeds what you can do anywhere else. We know in software and computer technologies, every time you get 10x, 100x scale improvements, new applications come up you didn't even think of before. And so in blockchain, this allows us to come into the applications of traditional SaaS and cloud. And just a little bit of a vanity slide here so that people have it if you go back to look at the presentation later. Ethereum, if you look at kind of the figure of merit of how much data you have available on chain, divided by what's the requirements of nodes that are validating the protocol. And so you can take a ratio of those two, and Ethereum gets you about 0.04 bytes of data per byte of data that has to flow through nodes. And you can look at the numbers here, which actually kind of go in the wrong direction, almost. Donk sharding finally gets you back to a nice 10x improvement. But even today, EigenDA is operating at the bleeding edge of efficiency, 50x, and really kind of blows everything else off the charts in terms of efficiency. And that's kind of a theme in EigenLayer. You'll see Sriram and some of the researchers. They're just very amazing information theoretical computer scientists. So part of the reason for betting on EigenLayer is that there's a roadmap of amazing technologies coming. It's not just about the financial aspects. Of course, it's both of them. Okay, so that's it for the blockchain SaaS side. Now, just briefly kind of going through the cloud. Adam touched on it, but I just want to kind of highlight a few points. He showed 15. It sort of comes out to, let's say, on the order of 10 to 20 SaaS services are integrated. This is in Web 2 now, not even blockchain. And so we want people to be able to build and experiment both looking at blockchain services as SaaS services already. You connect to them through RPC nodes, through APIs. But you also want to combine these together with existing Web 2. So Adam has the same slide, which is great. Great minds think alike. If you want to get a feeling for the amount of software as a service that's available on the cloud, just looking at what Google offers alone gives you an idea. And this goes thousands and thousands beyond this. This is how the software of the internet is built right now on these types of microservices. I have another review of it because you can barely read anything. This is, again, Google's view. It actually scrolls down like 8 pages of this, where you see the different categories, management tools, identity. You see the cluster of different SaaS services. It is notable, because the next slide I'm going to talk about this, that one of the issues with the cloud ecosystem has been that you end up extracting a lot of the value out of open source. I'm going to give you here a 40-year history of the computer science field. Back in the pre-2000s timeframe, before Amazon Cloud, this was how software was built. We transitioned from Windows and other things to Linux. We had open source software. People started monetizing Red Hat, other types of enterprise software around them. They sold them to end customers who ran them in their cloud. Next, the cloud came around, which is an amazing unlock for developers. But the cloud vendors noticed something, that they could cut out the software vendors. They could integrate the open source and just offer that for free, or in a scenario where they actually capture the value out of open source inside of their clouds. So I actually kind of attribute this to one of the big things. Cloud has been great for developers. It's been really bad for software providers, because it's kind of given up their control, that their software runs on one of the most antagonistic platforms that basically takes their value away. So that forked value capture, I sometimes talk about this, that open source software has a major issue right now. The happy part that I'd like to point out is, in part with decentralized protocols, but also with things like restaking and so forth, and decentralized physical infrastructure, decentralized public cloud, we actually can remove a central public cloud provider, pair it together with open source, and dApps can run directly on these two without having a central cloud provider. This unlocks the entire revenue of the current IT cloud space, brings it into blockchain, allows us to have digital assets, digital values, digital identity, digital data, all being managed through blockchains. This is the big fusion of the internet into the blockchain space. So, oops. Okay, and I'm just going to end here. If you go through the slides, there's one or two more, but just the themes on EigenLayer, just coming back to this to close the talk, is that shared security is strictly better. Everything I showed you on those last pages has this idea that you have thousands of services and you build given apps by putting together dozens of them into your given software application. By using restaking, you not only use Ethereum as a security layer, but you now use Ethereum to secure all of the SaaS that you've incorporated in your application. And this is sort of one of the central glues. You don't have to have a central public cloud provider. Your central public cloud security is being provided by Ethereum itself. And so that's why we kind of talk about $1 billion of restake security, and Adam was saying we're well over 10 billion at this point, can secure thousands of services, and that's strictly better than having tons of different blockchains with their own protocol, which much lower security per. Because security is the weakest link. Any service that you have, like if your oracles fail, your DeFi protocols fail. So there's this point here that you want to have as high as security across all of your software that you run. I'll skip these two. They have to do with like attributable insurance. And then the last point I want to make, it's blocked a little bit by the speaker here, but elastic scaling of security. The idea that as you're running an application, you may sometimes need 100 million of security when you have high value stuff flowing through, or during like sales season, who knows what. You may need billions of security. So similar to how Amazon brings elastic compute, elastic storage, EigenLayer and restaking allows you to dynamically change the amount of security so that you're buying what you need at a given point and otherwise not buying it. It's in sharp contrast to something like Ethereum, where the 50 billion in security is always there and you're always paying for it, whether you're doing a $100 transaction or $1 million. Okay, so I'll close it there and we will move to, yeah, thank you.